In this lecture, I want to talk about how to find the derivatives of common trig functions. For example, let's start with the derivative with respect to x of sine of x. How would we find the derivative of that? Now, one thing, if you've worked with GeoGebra at all, you could, we actually did this one in one of the labs, you traced out the slope of the tangent line at any point along sine x, and we already found that to be cosine of x. So kind of intuitively, graphically, if we were to graph the slope of the tangent line to sine of x at any point x, it would trace out the curve that is the graph of cosine of x. What I'd like to do here is just go through the derivation of it using the definition. So the derivative with respect to x of sine of x, just using the definition, that's the limit as h goes to 0 of sine of x plus h minus sine of x over h. That's just our definition, right? F of x plus h minus f of x over h. All right, so what can we do with this? Well, here's the key. We have an identity for if I have sine of something like x plus y. This is what you would see in a textbook or what you've seen in a trig class before. That is equal to sine of x cosine of y plus sine of y cosine of x. All right, so we're gonna apply that identity. So notice it's sine cosine plus sine cosine. It's just we have x y and then y x, and we're going to apply that with replacing the y. We're going to have h instead. All right, so let's go ahead, limit as h goes to 0, and then so that is going to be sine of x cosine of h instead of y plus sine of h cosine of x. That's just rewriting this first piece right here using the identity, and then we still have this minus sine of x on the end all over h. All right, so I want to move some things around here because ultimately we have a couple of identities. Recall that the limit as x goes to 0 of cosine of x minus 1 over x, we know that that limit is 0, and the other one was a limit as x goes to 0 of sine of x over x equals 1. All right, so those were just some common trig limits that we'd like to make use of in order to find this limit. All right, so we need to rearrange these things in such a way that we can make use of these limits that we already know. So let's rearrange this a little bit so that we end up with sine of x times cosine of h. And so what I'm going to do is regroup these by taking this and just switching them. Okay? So I'm going to have that minus sine of x, and then on the tail end I'm going to put plus sine of h cosine of x over h. All right, now I can break this up into two limits. Limit as h goes to 0, sine of x cosine of h minus sine of x over h plus the limit as h goes to 0 of sine of h cosine of x over h. All right, so again, we kind of think of, we could have combined these into one limit using the common denominator, so when we separate them back out again, we need to have an h in the denominator of each. H in each. Okay, so here I have a common factor of sine x that I can take out. So I have the limit h goes to 0 of sine x, and then that would leave me with cosine of h minus 1, and that's over h. Notice here we're getting close to this, right? Because our limit is with respect to h, so that looks like we might be able to get something out of there. And then similarly here, we could rewrite this as, well, we're going to do the same thing over here. So this is x, right? This is cosine of x. There's no h in it, so it can come out in front of the limit. We can think of it as constant with respect to h because there's no h in it. Similarly here, this can come out front. So I'm going to do that in this case first. Bring this cosine x out, and I'm going to have the limit as h goes to 0, just of sine of h over h. All right, again, the fact that we're calling it h instead of x doesn't matter, right? Ultimately, this limit will still equal 1. Similarly here, when I take this sine x out front, so I would have sine x, and then I would have the limit as h goes to 0 of cosine of h minus 1 over h. Well, we already know that limit is equal to 0. So, just kind of putting it all together here, I end up with sine of x times 0, because that's what this limit is, plus cosine of x times 1, because that's what this limit is. Well, that, of course, is just cosine of x, which is what our intuition told us when we looked at this graphically. Okay, so much for the derivation of the derivative of sine x. It can be shown that the derivative with respect to x of cosine of x is negative sine x. So we would go through something very similar to what we did here. I will spare you the derivation. You could probably, if you haven't looked at this, what you would need to do that is you would need the identity of cosine of x plus y. All right, but because you would end up with a cosine x plus h minus cosine x over h. You would have to use this identity to rewrite that, and everything would work out. So you can take my word for it. I think you'd rather do that than watch me do that one again. All right, so that gives us that one. Sorry, a little bit more paper here. I'm down to my last page. Okay, but let's take a look at the derivative with respect to x of tangent. All right. Well, tangent can be rewritten as sine over cosine. All right. So just by way of a reminder, so that we know the derivative of cosine is negative sine, we just derive the derivative of sine is cosine. All right. So if we use this identity, the tangent is sine over cosine, then we should be able to use the quotient rule in order to derive the derivative of tangent. So let's go ahead and do that. It's going to be a lot less painful than what we just did, because we can just use the quotient rule. So this is the derivative of sine x over cosine x. All right. So remember the quotient rule. It's the denominator times the derivative of the numerator. Right. The derivative of sine is cosine, minus the numerator times the derivative of the denominator, and the derivative of cosine is negative sine all over the denominator squared, cosine squared x. All right, so this gives us cosine squared x, and then so I have minus a negative, so these become positive, so I have cosine plus sine squared over cosine squared, but cosine squared plus sine squared is the same as sine squared plus cosine squared. That's our Pythagorean identity. That always equals 1. All right, and this, of course, is secant squared. Okay, and that's because secant of x is 1 over cosine of x. So if this is squared, then this is squared. We can think of this as being the whole thing, right? 1 over cosine of x squared, because 1 squared is 1 and cosine squared is cosine squared. Okay, so the derivative, just to kind of add to our little list up here at the top. So the derivative of cosine is negative sine, derivative of sine is cosine, and the derivative of tangent of x is secant squared. All right, I'm just going to do one more, and actually we have it right here. Let's figure out what the derivative of secant is. All right, because that could be. Well, once we do that, you can see that really we can just use the quotient rule again. If we do the derivative of secant of x, that's the derivative of 1 over cosine of x. All right, so if we use the, well, good, now to maybe a different color, I'm going to avoid this piece here, so let's come down here. Let's say that is going to be the denominator times the derivative of the numerator, and the derivative of 1 is 0, minus the numerator, which is 1, times the derivative of the denominator, which is minus sine x, over the denominator squared. Right? Okay, so now we can, this is minus a negative, so I end up with sine x over cosine squared x, right? Which I can rewrite as sine x over cosine x times cosine x. I mean, that's what cosine squared means. It's just cosine times cosine, which I then can write as 1 over cosine times sine over cosine, right? Because sine x is the same thing as 1 times sine x. And this right here, that's secant x. And this, of course, we've already seen, that's tangent x. So, the derivative of secant x is secant x tangent x. So here's another one that you should know. All right, so in addition to these three, and there are two more, and I'm just going to give them to you. We could derive them all using the quotient rule, but I will spare you that derivation. The derivative with respect to x of cosecant x, which is 1 over sine x, that gives us negative cosecant x times cotangent of x. So there's another one worth knowing. And finally, the derivative with respect to x of cotangent of x is negative cosecant squared. All right. So like the derivative of tangent was secant, the derivative of cotangent is cosecant, but it's got a negative on it. Similarly, the derivative of secant was secant tangent. The derivative of cosecant is cosecant cotangent with a negative on it. So notice that when you have a you have a co here, you have a co here, you have a co here, that the negatives always went with the cos. All right, if you have sine, tangent, secant, those aren't negative, those are positive. So that's just maybe one way to help you remember these. Okay, let's just see a couple of examples using these results. So there's 6 here, total of 6 that you will need to know. So 1, 2, 3, the 6 basic trig functions. You should know the derivatives of them. All right, let's look at an example using the product rule. So if my function is x sine x, let's find the second derivative. All right, so let's find f double prime. But of course, to do that, we first have to find the first derivative. So again, we use the product rule. So we can take the derivative of the first, which is 1, times the second, which is sine x, plus the first times the derivative of the second. The derivative of sine is cosine. All right, so this simplifies to sine x plus x cosine x. So to find the second derivative, well, I'll just need to use the product rule here, but that's going to be straightforward. That's just going to be cosine x. And then for the product rule on the second half, I have the derivative of the first, which is 1, times the second, which is cosine x, plus the first, which is x, times the derivative of the second, which is negative sine x. And notice I have 2 cosines, so I can write that as 2 cosine x, and then I can rewrite that as minus x sine x. All right, so that is the second derivative of this function here. Okay, just one more quick example. Haven't heard from e to the x in a while, so if we define g of x to be e to the x times sine x, let's find g prime of 0, which we can interpret graphically as the slope of the tangent line to this function at x equals 0. So g prime, we need to use the product rule once again, so it's the derivative of the first, and the derivative of e to the x is e to the x times the second, which is sine x, plus the first, which is e to the x, times the derivative of the second, which is cosine x. So g prime of 0 is e to the 0 sine of 0 plus e to the 0 cosine of 0. Well, e to the 0, anything to the 0 power is 1. Sine of 0 is 0 plus 1 times cosine of 0 is 1. That just leaves me 0 plus 1, which is 1. So the slope of the tangent line to this function at x equals 0 is 1. So that's it for the derivative of the 6 basic trig functions.